This video is about review for calculus continued. For number 7, let f prime of x equals this. Find the f of x given that f of pi over 4 equals to 1. So f of x equals, do the integral, sine third power 2x, cosine 2x. Then we got to use the substitution method to solve this integral. We will set up u equals. We always choose the trig function with higher exponents. Therefore, I will get the sine 2x. And du by dx equals sine 2x. We do derivative. That is cosine 2x times 2. When you check back this integral, we only have cosine 2x. So we need to solve for this cosine 2x here. We divide it by 2 both sides. You will get the 1/2 times du dx. This time, we need to plug in. That is u to the third power times 1/2 du dx. Then you have dx. So reduce. You will get u to the third power. That's 1/2 I take outside. Then du. So you get the 1/2 times u to the fourth power over 4 plus c, which means u to the fourth power over 8 plus c. Now I plug back in, which means f of x equals sine 2x to the fourth power over 8 plus c. According to the given information, f of pi over 4 equals to 1. We need to plug in pi over 4 into this function. You will get the sine fourth power of 2 times pi over 4. Then over 8 plus c equals to 1. Since sine 2 times pi over 4, that equals sine pi over 2 equals to 1. So you get the 1 to the fourth power over 8 plus c equals to 1. 1 over 8 plus c equals to 1. C equals 7 over 8. Now we plug back in here. You will get the f of x equals sine fourth power 2x over 8 plus 7 over 8. This will be the function for f of x. Let's go to 8a. Let y equals fx for x is between negative 0.5 and 6.5. The following diagram shows the graph of f prime, the derivative of f. The graph of f prime has a local maximum when x equals 2, a local minimum when x equals to 4, and it crosses the x-axis at point 50. Explain why the graph of f has a local minimum when x equals to 5. First of all, according to the given information, we know f prime of 5 equals to 0. Since at x equals to 5, the derivative of function is increasing, which means the second derivative is a positive, so concave up like this. This point will be minimum. So we can write down f prime of 5 equals to 0 and the second derivative of 5 greater than 0. So at x equals to 5, it's a minimum point. That's it. Just remember that if it's f prime of a equals to 0, then f double prime of a greater than 0 means a minimum point. Otherwise, if you have f prime of a equals to 0, and then the double prime of a that's less than 0, it will be maximum point. When second derivative positive, that means concave up. When second derivative is less than 0, means concave down. Remember, this is the rule for you to decide a point is minimum or maximum point. For 8b, find the set of values of x for which the graph of f is concave down. Concave down, which means the second derivative of a function less than 0, means the first derivative is decreasing. Therefore, just check from here to here, that's decreasing. So the set of x will be between 2 and 4. Or you can write down the interval form like this. Now let's go to 8c. The following diagram shows the shaded regions A, B, C. The regions are enclosed by the graph of f prime. The x-axis, the y-axis, and the line x equals 6. The area of the region A is 12. The area of region B equals 6.75. And the area of region C, that is 6.75. Given that f of 0 equals 14, find the f of 6. According to the given information, I can write down A equals, you have to do negative integral. That's from 0 to 2, f prime of fx. Then for the B equals still negative, definite integral, that's from 2 to 5. Then f prime of x dx. For C equals, this will be itself because above the x-axis is positive. So we have from 5 to 6, f prime of x dx. For the A, that equals 12. this equals 6.75. This equals 6.75. As we know, when we do indefinite integral f prime of x, you will get the f of x plus c. From a, since I have negative sign, I can do from 2 to 0 f prime of x dx equals to 12. So you get f of x from 2 to 0 equals 12. F of 0 minus f of 2 equals to 12. From b, still we switch this 2 and 5 because I have this negative sign. So you get from 5 to 2 f prime of fx dx equals 6.75, which means I have f of x, that's from 5 to 2, equals 6.75. So you will get the f of 2 minus f of 5 equals to 6.75. For C, you will get f of x from 5 to 6 equals 6.75. So we have f of 6 minus f of 5 equals 6.75. We are given this information, f of 0 equals 14. We are looking for f of 6. Now we get this equation and this equation. Then we have this equation. Let's label here it's 1, 2, 3. According to the given information, f of 0 equals 14. So we can get the f of 2 from 1. F of 2 equals, that is 14 minus 12 equals 2. Then f of 5 equals f of 2 minus 6.75, which means 2 minus 6.75 equals negative 4.75. Then for f of 6 equals f of 5 plus 6.75, which means negative 4.75 plus 6.75, which means 2. Now let's go to 8D. The following diagram shows the shaded area A, B, C, and the regions are enclosed by the graph of f prime. The x-axis, the y-axis, and the line x equals 6. The area A is 12, and B, that's 6.75, and C is 6.75. Let g of x equals f of x squared. Given that f prime of 6 equals 16. Find the equation of tangent to the graph of g at the point where x equals 6. From 8c, we already know f of 6 equals 2. If we want to get the equation of tangent to the graph of g at the point where x equals 6, we need to get the x1, y1, which means we need to get the 6 and a g of 6 first. That's your x1, y1. And also, we need to figure out the g prime of 6, because that will be the slope of a tangent line. So g of 6 equals, I plug in here, f of 6 square. F of 6 equals 2, so you get the 4. So your x1, y1 will be 6, 4. How you get this? Let's check g prime of x equals f of x squared. Then you do derivative, so that you can get the 2 f of x times f prime of x. You have to do power rule first, then do the derivative of f of x by using chain rule. Now we will get the g prime of 6 equals 2 times f of 6 times f prime of 6. That's you get the 2 times 2 times 16. This is given here. That equals 64. This will be the slope of a tangent line. Then we use y minus y1 equals slope x minus x1. We can write down the equation of a tangent line. That is y minus 4 equals 64 times x minus 6. This will be the answer to this question. Now let's go to number 6. You are given f prime equals 6x squared minus 5. Given that f of 2 equals negative 3, find the f of x. Remember, f of x equals f prime of x dx. Therefore, we will set up f of x equals, we just plug in this function, 6x squared minus 5. We do integral. So get 6 times x third power over 3 minus 5x plus c. That is 2x third power minus 5x plus c. You will get the f of x. Then according to this given information, f of 2 equals 2 times 2 to the third power minus 5 times 2 plus c. That equals negative 3. 2 times 2 to the third power, that's 16, minus 10 plus c equals negative 3. So c equals negative 3 minus 16 plus 10. You just need to move all constant number to the other side. Remember, you need to change the sign, so you get the negative 9. In other words, the f of x equals 2x third power minus 5x minus 9. That will be the f of x. Now let's go to 10a. Let f of x equals this. Show that f prime of x equals the natural log of x over x. So f prime of x equals 1/2 natural log of x squared. We do derivative. 1/2, that's coefficient you state. You have to use the power rule first. That means 2 times natural log of x. To the first power, that is the natural log of x, that multiplied by natural log of x. Do the derivative according to the chain rule. So you get, this is gone, natural log of x times 1 over x. which means natural log of x over x. Now let's go to 10b. There is a minimum on the graph of f. Find the x-coordinate of this minimum. When you talk about minimum or maximum, that means the first derivative equals to 0, which means I will set up natural log of x over x equals to 0. We know a over b equals to 0 means a equals to 0. Therefore, we will get the natural log of x equals to 0. The base is e, so we do e to the 0 power equals x. E to the 0 power equals x, which means x equals 1. C, let g of x equals 1 over x. The following diagram shows parts of the graphs of f prime and g. This g equals 1 over x. F prime, that equals natural log of x over x. According to the 10b, at x equals 1, there is a minimum point, which means f prime of 1 equals to 0. Therefore, this x-intercept will be 1, 0. The graph of f prime has an x-intercept at x equals p. Write down the value of p. P equals 1. Because this given information. For 10d, the graph of g intersects the graph of f prime when x equals q. So we need to figure out this q. You will set up these two functions equals to each other, which means 1 over x equals natural log of x over x. X is gone, so you get the natural log of x equals 1. Then the x equals, the base is e, so e to the first power equals x. E to the first power, that means e. So here it will be e and 1 over e. Because you plug this x into this function, then you can get the 1 over e. 10e, the graph of g intersects the graph of f prime when x equals q. Let R be the region enclosed by graph of f prime. The graph of g and the x equals p show that the area of R equals 1 over 2. I will draw this x equals 1, this line, intersect here. Then this area we are looking for. For this area, A equals, that's from 1 to this E. Because for your x-intercept, very left is 1, very right, that is E. So you have g minus f prime. Then you do dx. Let's separate, because you have f prime, then you can get the f. So we will do 1 to e. This is a g dx minus from 1 to e f prime of dx. Then for this, you will get the 1 over x. From here, you will get f, then you do 1 through e. This is a f function. So you will get here is a natural log of x squared over 2 from 1 to e. This part, you will get the natural log of x, then from 1 to e. So we do this separately for this. You will get the natural log of e minus natural log of 1. This gives you 1 minus 0. That's equals to 1. For this, I will do plus, then switch here from e to 1. So we plug in natural log of 1 squared over 2 minus natural log of e squared over 2. This is plus. This will be 0 minus, this is 1 over 2. So you get the 1 plus 0 minus 1/2 equals 1 over 2. Now we finish proving. Let's go to number 11. So we do the integral. That will be the area from 0 to 4. This is a definite integral of, here's x squared plus 1, then dx. We use u equals x squared plus 1. Then du by dx equals 2x. Since in this integral, we only have x, so we divide by 2 both sides. You will get the x equals 1/2 du dx. Then when you do the substitution for this definite integral, you have to get, this is your x1, x2. So get the u1 equals 0 squared plus 1 equals 1. For u2 equals 4 squared plus 1 equals 17. Now we can get the area equals, we do 1 to 17. And this is a u. Here is 1/2 du dx. Then times dx. Reduce. You will get definite integral 1/2 times 1 over u du from 1 to 17. Since 1/2 is a constant number, I take outside. 1 over u, that means natural log of u. We do from 1 to 17. That is 1/2 natural log of 17 minus natural log of 1. That is 1/2 natural log of 17 will be the solution.